between moles to moles. In the balanced chemical reaction equation, the coefficient represents the molar ratio. So if you're simply converting moles to moles, there's no other conversion involved. Okay, and as long as you use the correct conversion factor based on the balance coefficient, based on the in the balanced chemical reaction equation, you get the moles there. But this question asks you how many grams of carbon dioxide. If you consume this many grams of gasoline, how many grams of carbon dioxide can be produced? Now you're talking about mass in grams. Converting the mass in grams of gasoline into the mass in grams for carbon dioxide. Now, when you do this type of calculation, there is no direct relationship between the mass of the gasoline and the mass of carbon dioxide. The relationship, direct relationship, is between the moles. Every 2 moles of gasoline, octane, will react with 25 moles of oxygen, generating 16 moles of carbon dioxide. So what we need to do here is that this mass has to be converted into moles, so we can relate moles of gasoline to moles of carbon dioxide. When we figure out the number of moles of carbon dioxide there, we can convert it back into grams. So a lot of dimensional analysis is involved in this particular type of question. You have to go from grams of one reactant to moles of that reactant using molar mass as our conversion factor. And then moles of reactant to the moles of product using molar ratio in the balanced equation as our conversion factor. And then going from moles of product to grams of product using molar mass as our conversion factor. So multiple steps involved in here. Now you can see why the second exam is much more difficult. This kind of calculation is involved. 2 minutes. You only have 2 minutes to work on these kind of questions there. If I put 10 questions like this in there, I will use up all of your time there, not 25 questions in there. So it's going to be much more involved in terms of calculation. You have to know how to set up the equation. And knowing how to set it up is just one step to the first step. You have to be able to set it up quickly and solve the problem in 2 minutes or less so that you can get good grade on the exam there. Okay, so let's take a look at this particular calculation there. Okay, so what's given in there is that if we know the formula of the compound, then we know the molar mass. And if you're given using the periodic table, of course. So using the periodic table, knowing the formula, we can figure out the conversion factor. So in this case, we give that conversion factor to you. 1 mole of octane is equivalent to 114 grams. 1 mole of carbon dioxide, 44 grams. So if you have 1.2 times 10 to the 14, that's a huge number, grams of octane. First, we want to convert it into moles. Okay. Now, the conversion factor is given here. Each mole is 114 grams. We want the gram to be converted into moles. So where does the gram go? Where does the mole go? Dimensional analysis, nothing new. Okay. Plug in the conversion factor, gram and gram cancels out. So 1.2 times 10 to the 14th power divided by 114.22. We'll give you the answer. Okay. Someone punch in the calculator and let's write it out. So how many moles do we have here? 1.2 divided by 114. Ignore the 10 to the 14th there. We'll worry about the exponential part later. The 1.2 divided by 114.22. What do we get? 0.4105. I thought I can do that in my head. In Chinese. No, I can't. Say it again, please. 0.0105. All right? Okay. So that's times 10 to the 14th. Okay. Now that's not the correct format for scientific notation. We got to do scientific notation. Okay. So the scientific notation, that would be 1.05 times 10 to the 1, 2. You move it twice. 12. want to count on you with this calculation, assuming this is the correct calculation, okay? And you need to double check on that. So this is the number of moles of gasoline that we consume every day, that we use every day, okay, in this country. Now that we have 1.05 times 10 to the 12 mole of carbonate, hydrogen 18, we can figure out how many moles of carbon dioxide we're going to get. Well, the conversion factor is every 2 moles of octane will produce 16 mole of carbon dioxide. So 2 mole of carbonate, hydrogen 18, 16 mole of carbon dioxide. This number times 16 divided by 2. So this number times 8. Basically, what happens here is moles of gasoline cancels out. I will give you 8.40 times 10 to the 12 mole of carbon dioxide. The question is asking you how many grams of carbon dioxide will we produce every day when we use this much gasoline. Well, I should put the units in there just so we can see. So another dimensional analysis, moles of carbon dioxide converted into grams. Mole cancels out. That will give you the answer. Now if you punch in the number correctly, this is the answer you're supposed to get. 3.7 times 10 to the 14th gram. That's how much carbon dioxide we produce each and every day in this country by using gasoline alone. Now we use a lot of fossil fuel, coal, power plants to generate electricity. That also, when you burn coal to generate heat and using the heat to produce electricity, you also generate carbon dioxide. Okay, so gasoline alone will give you 3.7 times 10 to the 14th. Well, that number may not make much sense to you because we're not dealing with grams on a daily basis. We're not dealing with exponential numbers on a daily basis. Translate that into something that you can understand. That's equivalent to about 814 billion with a B, billion pounds. That's a lot of carbon dioxide. Now there's always a debate, and the next presidential election is coming up, and you see people start to, preparing to run for the office there, and this is always a debate, a topic in the debate there. Global warming, greenhouse gas. Carbon dioxide is known as a greenhouse gas, and the more you have on the planet, the more carbon dioxide is trapped within the atmosphere, and the higher the temperature is going to go. And you can do this experiment actually, and you can put a plastic, you can use a plastic film, and put it on use the plastic film to build a little greenhouse, and you will when you put that greenhouse under the sun, when you measure the temperature inside, and the temperature inside there is going to be much higher. And I do